Now I change from gravity to a spring. I have a spring which is relaxed length L. I call this x equals 0. And I extend it over a distance x. And there's a mass m at the end. And there will be a spring force. And that spring force, F equals minus kx. It's a one-dimensional situation, so I can write it without having to worry about the arrows. There is no friction here. It's clear that if I hold this in my hand, that the force of Walter Lewin equals plus kx. It's in the direction of increasing x. If I call this point A at x equals 0, and I call this point B at x equals x, then I can calculate the work that I have to do to bring it from A to B. So the work that Walter Lewin has to do to bring it from A to B is the integral in going from A to B of my force dx. It's a dot product, but since the angle between the two is 0 degrees, the cosine of the angle is 1, so I can forget about the fact that it's a dot product. I move it in this direction. So that becomes the integral in going from 0 to a position x of plus x plus kx dx, and that is 1/2 kx squared. And this is what we call the potential energy of the spring. This is potential energy. It means then that we, at x equals 0, we define potential energy to be 0. You don't have to do that, but it would be ridiculous to do it any other way. So in the case that we have the near-Earth situation of gravity, we had a choice where we put our 0 potential energy. In the case that we deal with very large distances, we do not have a choice anymore. We define it in such a way that the potential energy at infinity is 0. As a result of that, all potential energies are negative. And here, with the spring, you don't have a choice either. You choose at x equals 0, you choose potential energy to be 0. So if you now make a plot of the potential energy as a function of x, you get a parabola. And if you are here, if the object is here, then the force is always in the direction opposing the increasing potential energy. If you go this way, potential energy increases, so it's clear that the force is going to be in this direction. If you're here, the force is always in the direction opposing increasing potential energy. Increasing potential energy is in this direction, so the force is in this direction. You see, it's a restoring force. The force is always in the direction opposite to increasing potential energy. If you release an object here at 0 speed, it will therefore go towards lower potential energy. The force will drive it to lower potential energy.